Hello and welcome. If you're new to this channel, hi, I'm Anchita. Welcome to CodeGenix. In this channel, we discuss about all the things related to technology and programming. Today, we are going to discuss a Leetcode problem called median of two sorted arrays. So let's get started. Our problem statement is given two sorted arrays num1 and num2 of size m and n respectively. What we have to return is the median of the two sorted arrays. Follow-up of this problem statement is the overall runtime complexity should be big O of log of m plus n. Let us understand the problem statement. Here, the constraints given in the problem statements are both the arrays can have different sizes, the time complexity should be big O of log m plus n, and the elements in the arrays can be negative and positive in the given range, that is from negative 106 to positive 106. And also the overall time complexity of the solution that we have to put forward should be in big O of log m plus n. Let us understand the problem statement with an example. Given the array num1 with elements 1 and 3 and num2 with an element 2. We should get the median as 2. That is, when the array is merged to form 1, 2, 3, it should give the median as 2. If we are not considering the follow-up, that is, to get the time complexity as big O of log of m plus n, then there are several methods to solve this problem. We will discuss one by one here and last leading to our efficient solution with given time complexity. If you go by your intuition, the solution that you may find is first, merge two arrays, then sort them, then find the median, right? It is that simple, but it is not that efficient. Let me show you this with an example. We have an array A with elements 3, 9, 12 and 22. An array B with elements 1, 10, 19, 55 and 59. The first step is to merge this array to a new array called C. So now the array C will contain the following elements, that is 3, 9, 12, 22, 1, 10, 19, 55 and 59. The next step is to sort the array C, which gives us the value 1, 3, 9, 10, 12, 19, 22, 55 and 59. What we do next is we calculate the median. Since the total number of elements in the array C is 9, which is odd, we use the formula of median for odd, that is n plus 1 by 2, which gives us the value 5. So the fifth element of our array C is 12, which is the median. Here, the time complexity is big O of n plus m log of n plus m. This is because we merge and also we use a sorting algorithm. Now, the space complexity of the solution is big O of m plus n. This is because we used an extra array to store the combined array elements. By looking at the time complexity of previous solution, can we find another effective solution? Well, yes. We can do this by first going through the elements in array A and array B and then check the minimum value in these array and insert these elements in another array. Let us see this with an example. We are given two arrays with array A elements as 3, 9, 12, 22 and array B element as 1, 10, 19, 55 and 59. In first iteration, we compare 3 from array A and 1 from array B and we see which is minimum. Since minimum is 1, we will append 1 to the array C. In second iteration, we will compare for minimum value between 3 and 10. We can clearly see that 3 is less than 10. So, we will append 3 to the array C. In third iteration, we can compare 9 with 10 and we can see that 9 is less than 10. So, we will append 9 to our array C. In fourth iteration, we compare 12 and 10. That also clearly shows us that 10 is less than 12. So, we append 10 to array C. In fifth iteration, we compare 12 and 19 and we will check for the minimum value between them. Here, since 12 is less than 90, we will append 12 to array C. In sixth iteration, we compare 22 and 19. And we can see that 19 is less than 22. So we append 19 in array C. In seventh iteration, we compare 22 and 55 and we can clearly see that 22 is less than 55. So we append 22 to the array C. In last iteration, since we have no elements to compare in A, what we do is we will append the already sorted values of array B to array C. We then calculate the median using the formula n plus 1 by 2, as the number of the elements in the array is 9, which is odd. And with that, we get the median as 12. Here, the time complexity is big O of n plus m and space complexity is big O of n plus m. Look at the first two problems. See, they are less efficient in terms of space too. So, how can we solve this problem? We can solve this problem by eliminating the need to store the combined array in another array. How can we do this? We will discuss the solution with the help of an example. Consider the array A with elements A1 to A6 and array B with elements B1 to B8. The first thing that we have to do is to divide both the arrays into two parts, that is subarray X and subarray Y, such that the array should be equally partitioned, meaning the subarray X and subarray Y should have same number of elements. Let us understand this with the example shown on the top left corner of the screen. Here, red represents subarray X and green represents subarray Y. So have you understood how we divided subarray X and subarray Y? Let us move on to rest of the solution. We then find out the maximum of last element in both of the subarray X. Here it will be max of x2, b5. And we will also find the minimum of the first elements in both subarray Y. Here it will be minimum of a3, b6. Then we compare these values to see if subarray X element are less than the subarray Y element. If it is, then we calculate the median using odd or even formula according to the total number of elements in array A and array B. If it is not less than the subarray Y, what happens is that we will shift the maximum value in subarray X to subarray Y and minimum value in subarray Y to subarray X to balance out the array, just as shown in the bottom left side of the screen. We will get clear view with the help of an example. Given two array with elements 1, 4, 9, 68, 71, 78, 80, 82, 92, 98 and 5, 8, 14, 38, 41 and 49. Since we have total of 16 elements, we will divide the subarray X and subarray Y to 8. Our array is shown in the screen. Here, red represents subarray X and green represents subarray Y. We first find the maximum value of last elements in subarray X. Here, max of 78, 8, which is 78, and also we will find the minimum value of first element in subarray Y as minimum of 80, 40, which is 40. We then see if maximum of subarray X is less than minimum of subarray Y. Here it is not. So, we move 78 to subarray Y and move 14 to subarray X to balance the array. We then again check maximum of 71, 40, which is 71, and minimum of 78 and 38, which is 38. We then check if maximum of subarray X is less than the minimum of subarray Y. Here it is not. So, we move 71 to subarray Y and 38 to subarray X. We then again check the maximum of 68 and 38, which is 68, and also minimum of 71 and 41, which is 41. We then see if maximum of subarray X is less than subarray Y. Here it is not. So we move 68 to subarray Y and 41 to subarray X. Once again, we will check the maximum value between 9 and 41, which is 41, and minimum value between 68 and 49, which is 49. Then we will see if maximum of subarray X is less than the minimum of subarray Y. Here, 41 is obviously less than or equal to 49. As the condition is satisfied, what we will do is, we will find the median of this problem. Since the total number of elements is even, we use the formula for even elements, that is 41 plus 49 divided by 2 gives us 45. The time complexity of this solution is big O of min of n comma m. This is because we search for elements until we get the elements for which we want to find the median. And the space complexity of the solution is big O of 1. Here we can see that we have searched for elements in sorted array, right? For searching elements in sorted array, the best and efficient way is to use binary search rather than the linear one that we used in the earlier solution. So let's find out how to do the same problem with the help of binary search. Some conditions that we have to look into while doing this problem are when any one of the array is empty, or second condition, that is if any of the sub-array has only one element, and third condition when both of the sub-arrays has elements in them. We will first get to know the code for the solution, and later we will do a numerical problem to understand it clearly. This code here helps us to identify which array has less number of elements, so that later we can check if the array is empty or not. If we found that one of our array is empty, then we will immediately calculate and return the median. If not, we will set the boundaries for binary search and then partition our arrays into subarray X and subarray Y. Here, subarray X and subarray Y contain the index number of the element till which it is to be partitioned. After partitioning, we first check if subarray Y is empty or not. If it is empty, then we will check if X of subarray X minus 1 is less than or equal to Y of subarray of Y is satisfied or not. If satisfied, we check if the length of the elements is odd or even. If it is odd, we then see if subarray Y has only one element. If it has more than one element, we will return X of subarray X minus 1. Else, we will return max of X of subarray X minus 1, Y of subarray Y minus 1. If it is even, then we check same condition but returns the median using even. If any of these conditions are not satisfied, we reset Rx value, that is right index value, by subtracting 1 from the subarray Y. Similar is the case when subarray X has only one element. Except if the condition does not satisfy, we then reset the Lx value, that is the left index value, by adding 1 to the subarray X. If we have more than one elements in both the subarrays, we check if X of subarray X minus 1 is less than or equal to Y of subarray Y, and X of subarray X is greater than or equal to Y of subarray Y minus 1. We check if this condition satisfies or not. If it is satisfied, then we will check if it is odd or not. If it is odd, we will return the median using odd formula. And if it is even, we will return the median using even formula. If the condition doesn't satisfy, what we will do is we will update the Lx value. As the condition is not satisfied, we will update the left index value along with our subarray X and subarray Y value until we get a median. Let's understand more with the help of an example. Example 1. Given two arrays where array A is empty and array B has one element, that is 1. We then first check for the array which has less number of elements. Here A is empty. So what we do is we will assign A to X and B to Y. Then we check if we have any empty array or not. Since we have X as an empty array, what we will do next is we will enter the if statement and check if the total number of elements is odd or even. Since it is odd number of elements, what we do is we will return the median of the odd number of elements. Here it is 1. Example number 2. Given two array where array A contains element 5, 8, 14, 38, 41 and 49 and array B with element 1, 4, 9, 68, 71, 78, 80, 82, 92 and 98. First, we will look for the array with small size and then assign that small size array to x and large one to y. Here, we will assign A to x and B to y. We then check if any of the array is empty or not. Here, it is not. So, we will initialize the boundary values, that is, left index as 0 and right index as the length of the array x. Here, it is 6. We then partition the array to subarray x with index value till 3 and subarray y with index value till 5. We then check if x of subarray x minus 1 is less than or equal to and y of subarray y, and x of subarray x is greater than or equal to y of subarray y minus 1. Here it does not satisfy the condition, as 14 is less than or equal to 78, but 38 is not greater than or equal to 71. So, we move to the else if statement and check if x of subarray x minus 1 is greater than y of subarray y. This also does not satisfy, as 14 is not greater than 78. So, we will update our left index value to 4 and subarray x value to 5 and subarray y value to 3. Once again, we will check if x of subarray x minus 1 is less than or equal to y of subarray y and x of subarray x is greater than or equal to y of subarray y minus 1. Here it satisfies the condition, as 41 is less than or equal to 68 and also 49 is greater than or equal to 9. So, we check if the number of elements is odd or even. Here, it's even number of elements. So, what we do is, we will find the max of x of subarray x minus 1, y of subarray y minus 1 plus min of x of subarray x, y of subarray y by 2. That is 41 plus 49 divided by 2, which gives us the median 45. The time complexity of the solution is big O of log of m plus n, and the space complexity is big O of 1. Clear with the examples? Similarly, try the problem shown on the screen and also comment down the answer below. That is it for today. Hope you all understood the solution, and any queries regarding today's topic, comment down below. Thank you for watching, and make sure to like, share and subscribe, and also to press the bell icon so that you won't miss out my new videos. Until then, take care. Bye-bye.